In this video, we'll go over the most important things to look out for when optimizing your 3D file for the Synode platform. Let's get started. One of the most important things to look out for in your 3D models is the polygon count. The goal should always be to keep the polygon count as low as possible. That's because the more polygons a mesh has, the longer it takes for the software to render and load your models. For reference, we have two 3D models that are identical with the same level of visual quality. The differences between the two are the polygon count. This model has roughly 33,000 polygons, while this one only has 2,000 polygons. I can't stress enough that you should always factor in the polygon count in every 3D project you make. Now that we have the polygon count addressed, let's continue with other ways to ensure you have a clean 3D file, starting with merging your vertices. It is recommended to merge your vertices so that there are no polygons that aren't attached to your model. You can check to see if your vertices are merged by selecting your model and moving it around the world space to see if any polygons stay behind, like we have in this example here. To fix this issue, we want to make sure that the detached mesh and original mesh are one object, like so. Now that they are one mesh, now is the time to merge your vertices. So we go into edit mode, select everything, M for merge vertices, and merge by distance. Remove 12 vertices as seen at the bottom here, and it's merged by distance. So the next thing I want to talk about are n-gons, and why you should avoid them. N-gons are polygons that have 5 or more vertices, as seen here. Typically, you want your 3D model to be mainly made up of quads and triangles. You can see here in our scene that there is an n-gon on our object. If we go into the object preview mode, we can see that the light is reflecting strangely off our object. Now, to fix this, you want to make sure you have proper topology on your model, which is made up of quads and triangles. Now you can see that the light is reflecting as it should be. Having proper normals is essential. It ensures that the 3D model is being viewed correctly. Each polygon of a 3D model has its own normal that indicates the direction the surface is facing. You want to make sure that each polygon is facing outward. If your normals are facing inward, then your model will become transparent or pitch black. To see if you have any inverted normals in Blender, we can go to face orientation. Any inverted or weird normals are marked in red. To fix this, we'll go into edit mode, select our polygons that have the inverted normals, go to mesh, normals, and flip. We can now see that the polygons are now marked in blue. You should check your file to see if there are any duplications in your scene. Having unnecessary duplications will add more polygons, which is what we're trying to avoid. Having duplications may also cause visual errors such as z-fighting. Z-fighting is where two or more meshes are overlapping in the same world position and are fighting to see which one should be in front of the other. We can see in this example that there are two planes that are in the exact same world position, causing some very weird visual errors. Deleting your duplications will solve this issue. The pivot point should always be in the center of your 3D files. If the pivot point is off-center, this can affect the movement, rotation, and scale. Now, let's talk about mesh transforms and why you should apply them. When you just finish creating a 3D model, most likely you are going to have your location, rotation, and scale set at different values. If we exported our model with these numbers without applying transforms, it will take longer to load on other softwares and have an increase in file size. To apply your transforms and set them to the default value, first we want to select our object, head to Object, Apply, and All Transforms. We can now see here that all of our values are set to 0. During the 3D creation process, your software is constantly saving every change you make and gets stored as data. When your model is finished, this data is no longer necessary, as it will add more to your file size. To get rid of this data, let's go to File, Clean Up, and Purge Unused Data. Naming your meshes is highly recommended. That way it's easier to navigate the hierarchy and select specific meshes. Now, let's dive into the texture section of our 3D modeling process. Once you have the textures applied to your model, it's best to play around with the texture resolution. We can see here on the right that we have a model with 2048 pixels, while on the left, we have a model with 256 pixels. Side by side, you can see that the visual quality is drastically different. Keep in mind that the higher the texture resolution is, the longer it takes for softwares to load and render the pixels on your textures. Thank you for watching. If you have any questions, please feel free to leave them in the comments, or you can join our Discord in the description below.